This is my 16th video in my Casting Shadows series, and remember to subscribe to my YouTube channel. Let's draw a house together. Most houses are in two-point perspective. So these lines go to the right vanishing point, and these lines go to the left vanishing point. And you want this lower angle to be more than 90 degrees to avoid distortion. Now, draw these diagonals to find the middle of this side, and the peak of the gable is underneath that middle. How do we find how steep these roof lines should be? Well, one way is to find the vanishing point for each side of the roof. And these vanishing points are the same distance above and below the vanishing point for the house. The problem with this method is that look how small I have to make this house to find these vanishing points. So there really is a much easier method. I recommend drawing a roof by starting with two triangles with this one either the same size or a little smaller than the one in front, and then connect them with three lines. And what you've got is a triangular prism. To draw the lines inside the house, have them converge with the ones outside. So this one goes to the vanishing point on the right, and this one goes to the vanishing point on the left. Then put a roof over the triangular prism so that it overhangs it on all sides. Now, when putting in a door, I chose this eye level because this is about 3/4 of the way up the door, and that's the normal eye level for a standing adult looking at the house. Then find the middle of this side using diagonals. Once I had the middle of this side, I decided to put a door in, and the top of that door is usually the same as the top of the door in front. And then when you put windows, you want to find the center of both sides of the door. And then you put in the windows here. And again, the windows usually line up on top with the door. And your spacing generally should be slightly larger, close to the viewer, and smaller, further away from the viewer. To draw recessed doors and windows, make them the back of a box, as I've done here. The recession is indicated in two ways. One is the length of these receding lines, and the other is the position of this vertical pane. To find the position of that vertical pane, find the middle of the true window, and then that would be where the vertical pane would lie. But when we see it in perspective, you can see that it's closer to the left than the right. And as the recession gets larger, this pane continues to move to the left. Here are some window details to make it look more realistic. Start with the two little rectangles, the pink one and the yellow one, and then put the blue one on top of both of them so that it's above the pink one on top and it's below the yellow one on the bottom. And that puts eye level about in the middle. And for a standing adult looking at a window from the outside, this is about where his eye level would be. For shadows on gables from an overhang, connect the tip of the roof to the tip of the shadow, and that gives you the light direction. Now, the light is behind us here, so if it's directly behind us, then both of these shadows have the same degree of thickness. If it's to the left of us, then this side is thicker than this side. And as the sun gets lower in the sky, both sides get thinner. If you add color changes to the shadows of the rafters, it makes them more interesting. So imagine this is a horizontal rafter with a horizontal beam underneath and a vertical plane behind it. So the light hits the beam and comes to the back wall and gives us this blue shadow. And it probably does have a little bit of blue from the blue skylight. Now, if you have a horizontal plane down here, it will take the light and reflect it to form a secondary shadow underneath the rafter. And this is protected from the blue skylight, but it may have some dull orange or green from colors on the ground, like bushes and dirt. Here's a shadow under an overhang, and most of the shadow is bluish from the blue skylight. That blue is sent all over the place, but we only see it in the shadows and the shade because in the sun, the sunlight is so strong that it eliminates any blue in the light area. This yellow is from dirt or bushes below that hit the underside of the overhang and then goes to the shadow and then to our eye. So this area looks yellowish. When drawing a dormer, start with this rectangle, find its middle, and that will give us the peak of the dormer. And make sure this peak is separate from the roof line so they don't appear conflated. Then any horizontal lines like these go to a vanishing point on the left on eye level, and horizontal lines like these go to the right vanishing point. Then all other vanishing points go either to the upper or the lower vanishing point, which have vertical relationships with the right vanishing point. One way to find shadows of dormers on roofs is the wraparound. So we have this dormer here, a long seat that goes to the ground. And then we wrap this shadow line around this structure up the roof here and then down. And it will come down like this and intersect the light in two places. The problem is that if you have a very small shadow in it with a big object, this is prone to error. I want to show you how to find the shadow on this front view using a side view. So line up the two views as I did here. In this case, the overhang is the same distance from the dormer in all views. The light angle is 45 degrees, and the shadow here parallels the true incline of the roof. So this is the simplest scenario. So first, let's draw a light ray from the corner of the dormer roof down to the dormer itself to get line 1, and we can do that in both views. Next, we need to find point 3, and to do that, we go to the side view and find where the light hits the roof. That's as far as the light can go. So we transfer that position over to the front view, and that gives us point 3. Now line 2 here is parallel to its casting edge, which is the roof, and it ends where it hits the light from the tip of the roof right here. Now, to find the back of the dormer, we need the side view again to find where the dormer roof hits the real roof and transfer that position over here to find the end of this shadow. Again, we're looking for the shadows at the front view using the side view. So we can start with this shadow under the rafter, which is easily found by sending a light ray from the roof, and where it hits the dormer is the beginning of the shadow. But we don't know where number 2 is in the window without the side view. So on the side view, the light ray comes down and it hits the top of the window here at 1 and the back of the window at 2. So we transfer that position 2 over to here, and that gives us the horizontal and vertical shadows on the window. We also need the side view to find point 4. Now you could just make this shadow line parallel to the roof, but if they aren't parallel, then you need to find point 4 on the side, which is where the roof of the dormer hits the main roof. You transfer that over to the front view, and then you have this incline. The problem with this method is that architectural references use the conventional light ray, which makes a 45-degree angle in all views. But that almost never happens. For example, this light ray is about 45 degrees in the front view, but on the side view, we see that it's nearly overhead. So you would need to find the light direction in both views before you can use this method. Then we can proceed as we did before, namely, line up the two views at number 1 and 4. So they line up over here in the front view, 1 and 4. Then draw a light ray from the tip of this roof down to the lower roof to identify number 2, and find number 2 over here on the side view where light from the tip of the roof hits the roof. Then draw a light ray here from another roof down to number 3 and find that position here on the front view where the light hits the roof below. And then the shadow parallels its casting surface here. Now the other problem is that we can't use the perspective view. I lined up number 2 and 3 with the other views, but number 1 and 4 are off because it's in perspective. If an overhang casts its shadow on a vertical structure, the shadow line is horizontal. But if that surface has components that are further away or more nearby, the shadow line changes. For a bird's eye view, the shadow line for the recessed part is higher than the shadow line in front. This block is behind this block, and we're looking at it from a bird's eye view, so this shadow line is higher than this one. If, however, we're looking at it from a worm's eye view, the opposite occurs. The shadow line on the recessed part is lower than the part in front, so this shadow line is lower than this one. And we see that often in buildings. Here, this shadow line is lower than the part in front. And this displacement increases if the two structures are more displaced. And also, as we go away from eye level, this displacement increases. I want to show you how to find these two shadow lines. So let's start on this green box, and where it hits the red box, the shadow line changes so it follows the perspective of the red box. When it reaches the front corner of the red box, that's the shadow line for the red box. I drew a light ray from the tip of the roof to the end of the shadow. This light ray is steeper than the roof. As a result, this side is in shade and casts a shadow, whereas this one does not. Then draw a light ray from this front corner to the corner of the shadow. We don't know where this corner is without a side view, but once we have it, we know the shadow is horizontal until it intersects the light, then it goes vertically up until it intersects the light from the shadow line here, then it follows the roof, so it goes horizontally across, and it ends where the roof touches the wall. My next video is about shadows of ellipses, so we'll start getting into round forms.